Hello viewers, in today's class we are going to discuss one very important problem from derivatives, right? And here we have to find the first order and the second order derivative of sine cube x with respect to cos cube x at x is equal to pi by 4, right? So here we have the concept of finding out the derivative of a function with respect to another function, right? So here we are given the first function as sine cube x, and we have to find the first derivative and the second derivative of sine cube x with respect to some other function which is cos cube x, right? So here we have the concept of derivative of one function with respect to another function. So in such cases, what we do, we assume the first function as u, right? So we'll take u is equal to sine cube x and v as cos of cube x, right? So we'll assume u is equal to sine cube x and v is equal to cos cube x, right? And we have to find here du over dv, right? Because u is sine cube x, v is cos cube x, and we have to find the first order derivative of sine cube x with respect to cos cube x. So we have to find du over dv at x is equal to pi by 4, and then once we calculate du over dv, we can find the second derivative of u with respect to the function cos cube x, right? So we'll find d2u over dv2 at x is equal to pi by 4, right? So now let us first find du over dx, right, and dv over dx. So first we'll find the derivative of u with respect to x. So this is d by dx of sine cube x, and here also we'll find the derivative of v with respect to x. That is d by dx of cos cube x, right? So now see here to find out the derivative of sine cube x with respect to x and the derivative of cos cube x with respect to x, will make use of one important result, that is the derivative of x raised to n with respect to x is nx n minus 1, right? So here we'll write the derivative of sine cube x as 3 sine square x, and then by chain rule we'll find the derivative of sine x with respect to x, right? So we have n is equal to 3, and for x we have sine x. So 3 minus 1 is 2, so 3 sine square x d by dx of sine x, and the derivative of sine x with respect to x is cosine x. So this is du over dx, right? Similarly here we'll find the derivative of cos cube x with respect to x by using this result. So we have n is equal to 3, so we have 3 cos square x. Then the by chain rule the derivative of cos x, right? So this is 3 cos square x, and here the derivative of cos x with respect to x is minus sine x. So we have minus 3 cos square x sine x, right? So we have obtained du over dx and dv over dx. So now we have to find a du over dv, right? So the formula for finding out du over dv is du over dx divided by dv over dx, right? So this is the formula for finding out the derivative of one function with respect to another. That is du over dv is du over dx divided by dv by dx. So du over dv is now du over dx. This is 3 sine square x cos x divided by minus 3 cos square x sin x, right? And we can see that some terms get cancelled here, 3 and 3 get cancelled, and we are left with minus sin x over cos x, right? That is equal to minus tan x. So the derivative of u with respect to v is given by negative of tan x, right? So now the first order derivative of sine cube with respect to cos cube x is given by this expression, right? And at x is equal to pi by 4, we can find out the derivative, that is du over dv at x is equal to pi by 4 is given by substituting x is equal to pi by 4 in this expression, that is minus tan x. So this is tan pi by 4, right? And tan pi by 4 is tan 45 degrees, so this is 1, so we have minus 1, right? So du over dv at x is equal to pi by 4 is equal to minus 1. So now we have to find the second order derivative, that is d2u over dv2, right? So d2u over dv2 can be written as d by dv of du over dv, right? So by definition of second order derivative, d2u over dv2 is written as d by dv of du over dv, right? Now du over dv is given as minus 10x, right? So here we'll write minus 10x, right? Now we can take this negative sign outside, so we have d by dv of 10x, right? So now here we see that we have to find the derivative of 10x with respect to v, right? So what we will do here, we'll make use of the chain rule, right? So chain rule says that here we'll replace v by x, right? So first we'll find out the derivative of 10x with respect to x. Then by chain rule, here we will write dx, that is this term dx over dv, right? So by chain rule, now we have this expression. So the derivative of 10x with respect to x is secant square x, right? And dx over dv can be obtained by this expression, right? So here we have dv over dx. So this is minus 3 cos square x sin x, but we require dx over dv, so we'll take the reciprocal of this term, right? So here we have 1, so this is 1 over minus 3 cos square x sin x, right? So now we can simplify this expression. So this negative sign and this negative sign get cancelled. For cos sec square x, we can write cos square x, and here we have 1 over 3 cos square x sin x, right? So now multiplying cos square x with cos square x, we have 1 over 3 sin x, and then we have cos 4x, right? So we have the power of cos x as 4, right? So this is the second order derivative of u with respect to v, and u is sin cube x and v is cos cube x, right? Now we have to find the second order derivative at x is equal to pi by 4. So what we will do, we'll substitute x is equal to pi by 4 in this expression. So we have 1 over 3 sine pi by 4, and here we have cos 4, and here we have pi by 4, right? So sine pi by 4 is equal to 1 over root 2. Similarly, cos pi by 4 is also equal to 1 over root 2, right? So here we have 1 over 3 times 1 over root 2. Then we have 1 over root 2 raised to 4, right? So simplifying this expression, we have 1 over 3 over root 2 times 1 over 4, because root 2 raised to 4 is 4, right? So taking 4 root 2 to the numerator, we have 4 root 2 divided by 3, right? So the second order derivative of sine cube x with respect to cos cube x at x is equal to pi by 4 is 4 root 2 divided by 3,